Okay, let's start our data collection for the Calorimetry Lab. Now, I've already run the simulations on Explore Learning. We're going to start first with a cube of copper. Now, my initial copper temperature, I'm setting at 98 degrees Celsius. And the initial mass of my copper, I'm setting at 199 grams. Then my initial temperature for my water is being set at 26 degrees Celsius, and my initial mass of water is 600 grams. Now, I like to color code things, so that's why I'm using a color code system, but you're welcome to do this however you please. Okay, so now I'm going to click on the graph, and I'm going to run the simulation. And my copper gets cold very fast. There's a slight rise in my water, but they both end at the same temperature, which is 28.09 degrees Celsius. 28.09 degrees Celsius. I'm going to circle back and do one example of change in temperature, but I'm going to leave the rest of that to you. So now on to our lead trial. My starting temperature of my lead is going to be 99 degrees Celsius. And the initial mass of my lead is 199 grams. I'm going to keep the same mass of water, 600 grams. And I've set my initial water temperature to be 25 degrees Celsius. Okay, so now I'm going to go to the graph, run the simulation. Water gets warmer, the lead gets a lot colder, and they both end at the same final temperature, which is 25.73 degrees Celsius. 25.73 degrees Celsius. And now our last one is the granite. So the initial temperature of my granite, I'm setting at 100 degrees Celsius. And its initial mass, I'm setting at 200 grams. My water mass, once again, I'm going to keep this at 600 grams. And my starting temperature is now 24 degrees Celsius. I'm trying to make this as similar to a real lab as possible. So if I gave you three 200-gram masses and I gave you water from the same faucet, why might you get these slightly different numbers? Something to think about. All right, so now I'm going to go up and start the simulation. The granite cools, the water warms, and they meet at the same final temperature, which is 28.53 degrees Celsius. 28.53 degrees Celsius. All right, now what you need to do, now that you have all this raw data, you need to start processing it before we can actually start plugging it into our equations. So I need to find the change in temperatures, because when you plug this into Q equals MCAT, you don't actually use the initial or final temperature. You really only want the change. So my change in water is the final temperature minus the initial temperature of the water. So my final temperature is 28.09 degrees Celsius. And I'm going to subtract my initial water temperature, which is 26 degrees Celsius. Now, I'm sure most of you are doing this in your head right now, but this is chemistry. I always strongly encourage getting out your calculator. So 28.09 minus 26 gives us 2.09 degrees Celsius. And then, oh wait, so I put that right here, 2.09 degrees Celsius. And then I want to find the change in temperature of my metal. So I take the final temperature of my metal, my copper, 28.09 degrees Celsius. And I'm going to subtract my initial temperature of my metal, my copper metal, which was 98 degrees Celsius. So clear. And I have 28.09 minus 98. That gives me negative 69.91 degrees Celsius. So my change in temperature for my copper was negative 69.91 degrees Celsius. I'm going to let you do the last four. It's just a subtraction. I would like you to notice, hopefully, that all of your metal cubes should be negative changes, and all of your water is going to be positive changes. Good luck!